So, okay. So welcome to my talk. It's more a live coding session, so I'm kind of nervous if it all works out correctly. So I have no slides, but I have an application prepared, which is a little React application. Pretty simple. It has an index file, which just ports React, React DOM, Hello World, appends it, render it, has a component which do some lazy loading because it's cool, and imports this big text component which is super awesome because it's rendered some header tag, and it has this lazy component which also rendered something big. And yes, this is the basic application. In this case, I bundle this with Webpack, so some basic configuration here. Always production mode is cool. And we use a Babel loader. And because I want to try to bundle this application without Webpack, just by coding, I did some small modification because React is about 10 modules in NPM, and so I pre-bundled React, this React bundle, and mapped React and React DOM to this React bundle, which is kind of built here. It's pretty simple, just importing everything from React. So it's easier for me to manage in this live demonstration. And yeah, we try to bundle it, just one Webpack, and it has, in some time, it has the result. It renders a main.js file which contains my code and React, and an async file which contains the lazy loaded part and has this 3 modules. It's actually 4 modules. If you display all modules, oh, typo, no. The 4 modules because it's also the React bundle. And I try to bundle it via live coding. So in the first step, we try to build the module graph from this application. So I created this little task. And the first step is to add the entry point to the module list, because Webpack defaults to /source in the current directory. This is the first task in the to-do list. And the first step Webpack does, and I do also in this live coding, is to resolve it to some absolute path. And in this case, I look in this folder, which is called source, and try to find an index file, and I found one, and this will resolve to source index.js. And the next step is to add this cool module to the module graph, but not this, because we have to use Babel. And to use Babel, I use Babel instead of the Babel loader, and transpile this module, only one, because Webpack also only knows about this module at this time. We transpile it into my folder, in this module graph modules folder. So transpiled, awesome. Now we can open this module after transpilation and parse it. Where's the module?
Hit the refresh.
Yeah, hit the refresh. Oh no. Doesn't work. Oh my god. Just failed in the first second. Okay, now we parse this file, and parsing means we're looking for import statement, and we found some. So we take a note of this, and this file has a React import, and then a React DOM import, and a Hello World import. And the next step is after parsing, we have all these imports, and we add all these imports to our to-do list, and we add React. Because everything is alias to React bundle, we only add React bundle in source folder, and also this small little module Hello World in my source folder. And then it's done, the first task. We continue with the next one, resolve this. Resolve this to React bundle. We don't care about the right part. And same thing, we add React bundle.js and pass it. We don't transpile it because it's excluded, but we copy it to our in-memory cache of modules, which is this folder here. So we copy React bundle slash node module slash bundle to one modules slash React bundle copied, and we pass it. Okay. I prepared this. There is no require statement in this. Great. Nothing to do. Okay, next one. We resolve the hello world, and the hello world resolves to source slash hello world .js, and that's next step. We run Babel on hello world and hit the refresh button because it doesn't work. And we pass this file. Okay, Babel did a lot of stuff here. Maybe we don't need it, but it transpiles classes. Okay, we look for imports. We don't care about the code. Import. Webpack only cares about imports and requires. Doesn't care about the code. And we added to the module graph source hello world.js and have React. And we have this dependency on big text. This is our ASA module. And we found another import, it is this module. It's kind of lazy, okay, it's kind of the same. We maybe take a note that this is an async import. Lazy. One thing that Webpack does also is to take a note about if this is an ECMAScript module, and these both modules are, but this module isn't one because it doesn't contain an import and export. Okay, we are done with this module. Done. Just add the dependencies to our to-do list. Big text. Okay, you get the idea? I do it a little bit faster because we have no time. Big text resources, and also the same for lazy in source. And we solve this to source lazy, and we do the same thing. We add these modules to our graph, big text.js, which is also as we have to execute Babel with big text, and because we are lazy, we're doing this in parallel. Webpack also does this in parallel, so it's fine. Lazy too, and we pass these modules. The imports lazy and it's easier to do. Oh, we missed the wrong one. Big text. So big text has an import to React, so React, and this other module called lazy is also just a standard explicit modules. Also contains a reference to React and a reference to big text. We also add this to the to-do list, but it's already done, so we're done. So the next step, we already connect the modules, so we add the actual dependencies. This is all the pre-resolved stuff, and now we note the actual modules. So we have this one, and we have source.hello.js, and it has no dependencies. This one has React bundle.js and big source, big text. Where's the big text? Oh, typo. It's very important to get this right. And we have this async imported lazy module. This always takes to care about the async stuff because it's later important. React bundle.js, and we have this React bundle.js, and also the source.bigtext.js. Okay, done. We have a model graph, which is kind of list, but if you see this as links, it's a graph. So, next step is to make an chunk graph. The chunk graph is the kind of how Webpack splits the application into parts. And to do this, we just have this file here and move it to the side. And basically, we do the same thing. We add the entry point, which is kind of, what was the entry point? Source.index.js should be in call main. So we create a chunk entry point main, which contains a chunk also named main, and then we execute this to-do list and put this module into the main chunk. Pretty simple. Now we do the same for every dependency of this. So this is the dependencies. So we create new to-do items. We have React bundle to main, and we have source.hello world.js to main, and done with the first. Done with the first task. Now the second task, we put React bundle into the main. Very easy. And done. That's easy. And we put hello world into main. This is a bit more difficult because it has dependencies, and we check for the dependencies, or all those dependencies. So we add React bundle to the main, or that's already done, don't have to do this. We have add main text into main. Yeah, we will do this later. Note this on the to-do list, and this is an async chunk. We need to do something special, and for an async dependency, we just create another chunk group, and call this async, and this and chunk. Oh, come on, chunk. All the async, and we note this on the to-do list to move lazy.js into async. Okay, done with hello world. We add big text to main. Big text has no dependencies. Oh, it has dependencies. React bundle, but this is already done in this task, so done. Now we add lazy to async, the same scheme. Lazy has dependencies. React bundle. Okay, we have to add a new to-do list. React bundle has to also go into async, and big text has also gone to async. And you get the idea. We put everything into this little chunk. React bundle and big text. Oh, yes. Oh, I did it wrong. Wait, fix it. Okay. Everything done. And now you see the problem. This is duplicated into multiple chunks. So Webpack does an optimization step. We also do this optimization step. Move this to the right. Close this one. And the next step is an optimization step. So we basically copy the graph and do this kind of name, the optimization named optimize available modules. It's also in this kind of Webpack option optimization available modules. It's on by default, so okay, we do it. And this basically for each chunk group, this is this kind of this chunk group and this chunk group, we take a note of all available modules. So which modules are available when loading this chunk group. And for the entry point, no modules are available yet, so it's an empty array. But for the async chunk, and we missed something. We have to note that this has a parent called main. Missed this in the last step. So, and now we can create a list of available modules by getting all modules from, so the intersection of all modules available in all parent modules, which is basically a copy of this list. And now we can see if we check for every module, we check if it's already available, and then we can remove it because it's already available. So lazy isn't available, rectangle is available, so we remove it, and BigText is also available, so we also remove it. Now we have a better chunk graph. Great. So next step. This is a more complicated step. It's scope hoisting. You saw in the SV1 Webpack, it concatenated two modules together, so it's kind of done scope hoisting with these modules, and we have to run it manually. So there's a little algorithm to do this, and you basically copy the module graph, which is this one, copy this one, this graph, and we have some kinds of rules when to scope hoist modules, and there are two rules. There are rules for the scope hoisting, which are kind of entry point for the scope hoisting, and there are kind of rules which when a module can be a child of a root. So we start on the bottom because it's cooler, and the first rule is one more place. So every module could be root. So we check if it's an ESM module, and there's only one module which is not an ESM module because it's a CommonJS module, and this can't be a root, so we can cross it out. And so every other module could be a root, and so we try to find children for each of this module, which can be dependencies. So first rule is must be normal import. So React Bundle is a normal import, great, and BigText also. It must be in the same chunks. So you could make a note in which chunks this module is. So this is in the main chunk, and this is one too, and this one too, this one too. So is BigText in the same chunks and lazy? No, it's not. So not same chunks. Doesn't work. React Bundle. This doesn't work because it's not an ESM module. Actually, then it should be copied to the child. Not ESM. So sadly, lazy can't be scope hoisted. So to try this with BigText, same, not ESM, doesn't work. So we try this with Hello World. So this one doesn't work. This one could work. It's in ESM. It's included with a normal import. It's in the same chunks, yeah. And all importers must be included. So if we include a module into a scope hoist, we can't access it from. It's no longer accessible by other modules. So every module importing this module must be in the scope hoist group too. So does it work for this? And we have to include lazy to make this true, but this doesn't work because lazy is not in the same chunks. And here's an async import, but it must be a normal import, so this doesn't work too, not normal import. Okay, this doesn't work because it's not ESM. And this one, maybe it works. Okay, React Bundle doesn't work because it's not ESM, but Hello World is ESM, yes. It's a normal import, yes. And in the same chunk, yes. And all importers must be included. Luckily, we are the only importer, so it works. And so, yep, okay, could be included. And now we try to, optionally, include all dependencies. So we basically copy this one, all dependencies, into this one and try this too. It's kind of recursive process, but we also already identified that it wouldn't work. So the only scope host group is index with hello world, and to write it. Just fix the module graph to create this group. So basically, say now we have the old module. Copy, paste. So basically, we put these module into a module. Webpack usually gives it the name plus one module, and puts this one into the group and also this one into the group. And scope hoisting also means to hoist all imports, all dependencies, and all dependencies of the graph into these modules. And we can delete duplicates because it's no. So done with a new model graph and a scope hoisted module. So now the easy steps. We have this module graph, and we want to give every module, every chunk an ID. Okay, that's pretty easy because just randomly choose an ID. So we copy the graph and give every module an ID, and just start with 0 and continue with the magic number 1, and obviously the 2, and now we take an 8. It doesn't matter, you can give every module, okay, we give it 3. Give any number. So it's the same screw with the chunk graph. So we have the chunk graph here. Oh, we have the chunk graph. It's better to optimize chunk graph here. Copy this one into this step. Close this one. And yeah, this is old information. No longer needs this. Not even store it in that way. So we give it a number. 0 and 1. The chunk groups are not relevant for the generated code, so they don't need to have an ID. Webpack usually sorts the module and gives the module the chunks and the modules IDs in sorted order, where it's sorted by how often you use it. So more often used modules get a smaller ID, and less often used modules get a higher ID. Why? Because smaller IDs are usually shorter in the code than higher IDs. So if you get more than 10 modules, you see it's different because one number and 2 digits. So that's the idea, to make the bundle as small as possible. Okay, this was the easy steps. Now we have to generate code. Okay. Okay, we can close everything else. And to generate code, we have to generate code for all the modules. So we just copy the modules, and I also prepared a runtime file, which will contain the runtime, because Webpack, the bundles are basically contains the runtime code and the list of modules. So we going to write the runtime code because we don't have Webpack available, and we also have a chunk file because the chunk also needs a small part of runtime to inject communicate with the original runtime. So, but we start with the modules. So the modules are, we start with a lazy module. It's very easy. So we need, we start with big text, it's easier. So because the browser, at least if bundled, the browser doesn't understand this import and this export syntax, we have to generate code instead. And we just generate code and we may just have let's take the magic function which returns the exports of this module. And because we don't have names, we need some ID for the React bundle and check the dependency graph. It's 1. So magic function of 1 returns the exports of the React module. And so basically this import means the same as default. So we have to replace this with x.default. So done. Can delete this one, and we can we just use an object to store this one. So okay, because the magic and exports isn't available in the browser, we need to wrap this module into a function and pass this magic function and this exports object into the module. So this like this. Maybe you've seen this before. But to make this work, we need some kind of runtime code. So we need to write a runtime, and the runtime basically has some kind of we have a kind of modules array, where we later store all the modules to do insert modules here. And we have a kind of function with magic with an ID. And now we have to load this module, any other module. So how do we do this? We have this modules array accessed by ID, super simple, and call this with the magic function. And this exports object. And just create one. And after that, just return one, return exports. So, good work for this module. So let's continue with another module. Let's use the React bundle. It's a difficult one. So we just don't care about the code. We just wrap this inf module which passes the magic and the exports. No, it uses the module. Okay, we pass also the module. Okay, just take all this code, just kind of React, and to make it close this function. Okay, so but we have passed this module, so we also expand our runtime to take this module, and because it's module exports, it's a bit different. We rewrite this module with exports object. And kill this line. And instead of exports, we passing module to exports. And we also return module to exports. Okay, we should work now. Great. Okay. Okay, magic, the lazy module. It's also a simple one. Oh, we including React, so that's basically we can copy this because we are copy paste components. Magic import. X is replaced with x.default, and this line is removed. So same for big text or some other thing with this ID. ID is big text. Big text is two. Big text removes this big text, and we take default. We made a mistake. Save it. We executing magic2 twice, so we get two different instances of React because we're executing this twice. So we need a kind of caching mechanism within the runtime. So we need to create a cache object because every good JavaScript developer stores stuff in objects. And so we just cache access to the cache the stuff. Caching is pretty simple, just return cache ID, if it's cached, then return cache ID.exports. Easy. Caching. Okay, this one exports.default, and we have to add this cool function wrapper. Function wrappers are great. Exports. Yeah, well, here, in correct intention is pretty important. Okay, so next one. It's a difficult one because it's scope hoisted. So this one, index. Maybe we should optimize this a bit because if you arrays, no. So basically modules, so it's kind of scoping is in JavaScript common. So this kind of cache variable leaks into our modules array. So what we do to prevent leaking, we use an IFI. We just pass the modules here and put everything into an IFI and copy this one. Insert modules here. Insert modules now here. Because, it's pretty important to use this exclamation mark. Okay, it should work now. Maybe. Okay, let's call this done for now. So this complicated one. So the React stuff is easy. Copy this one. X React. We will replace React to this. X.default. Render is also x.render. Hello world. Okay, hello world. It doesn't have an idea because it's scope hoisting. Scope hoisting could be easy. We just copy this one. Copy this file into this file. Okay, and because every import is hoisted, everybody knows who reads the spec knows this. So React, we do this already. So React left, React dot. Okay, we just replace everything with x.default. Something that I did wrong. So again, React was right. React dip x.default. Don't replace too much. Crashes everything. Default. So what we also have to do is, we deleted one line. So basically, it's the default export, and there was this import hello world from anywhere, and we basically rename the stuff to make this identifier and this identifier equal, and luckily its name's the same, so we just can remove this one, and it should work. Yeah. And now what's the component? Did you miss something? Oh, big text. Big text is why magic. Big text is 2. So where's big text? Is y.default. Default. And we remove this line. And this one thing here left, import, this async import, a bit difficult. Let's start with something else. Make this cool. Magic exports. Indent everything. And close it. So now we have to do this. Okay, let's assume we have some kind of function, this kind of function Lord chunk, which loads a chunk, and we have this chunk with the ID 0. Okay, 0. And let's assume it returns a promise. And now we have magically all modules in this chunk available. So, and if we have everything available, we have to just call this magic function. And because we are super fancy, we use bind. And we bind it to this lazy module ID 3. And this returns a promise, and it returns the promise of this module, and yeah, I think it's done. Okay, great. Maybe we should write this Lord chunk function. We don't want to include in this function. We just namespace it the magic function. Because functions with properties is super awesome. Okay, there's the runtime. Where's the runtime? So let's write some kind of magic Lord chunk function. Chunk ID. So, yep, we how to load a JavaScript file. Everybody does this with script text. So document, create, element, script. So, and script needs a source. Let's assume we load this at one day bundler / last step assets / now it needs a name of this chunk, and it could be any chunk with an ID, and because we only have IDs, we need to map this. So let's take a look at the graph again. So we could load this module, and yeah, so we have some kind of mapping 0 is async, and call this with chunk ID. And prepare JS. Could work. We missed something. Document dot head dot append child script. It doesn't work for all browsers, but it should work. Okay, we need to return a promise. Maybe we should have some kind of mechanisms to, after loading this script tag, to inject all the modules in the chunk, which is this one, to do add modules here. We have some kind of mechanisms to put this back into this modules object, and because JSONP is so popular, we could do this with this mechanism. So we just register a magic JSONP function, and new modules, blah blah, and because for in is the most popular for an ID in new modules. Modules ID is equals to new modules ID, and we just call this function window.magic JSONP with an object of all new modules. Should work. Okay, maybe we should return a promise here, because we promised this in the module, new promise. And yeah, resolve, rejecting this. So unpopular. Error handling is, nobody cares about error handling. Okay, how to resolve this? We need to call this resolve module at this JSONP, and we need to store it somewhere. So we will take one and call it chunk resolve. And it's also an object. Cool. And chunk resolve it, store this cool function at this point. So chunk resolve it, chunk ID calls. We have no chunk ID. Yeah, just passes here. And it's this module here, module 0. 0, it's of 0 because the ID of the chunk is 0, obviously. Okay. Good. So, did we miss? We need to execute the entry point. Don't miss it. Magic. And the entry point is ID number 0. Magic. Okay, let's call this done. Anything I missed?
Yes. Hello world, line 2.
Hello world, line 2.
Just have a look. I think it's...
But we copied this file into this file. Okay. So, just delete it. I did delete it. Delete it.
You wrote something while indenting in Hello World, but I don't know where it is now. So
it's deleted.
Okay. Yeah.
This one, you take this one.
Yeah, you just grabbed it and indented and broke something, but okay.
I bought something? Could be.
I thought it was Hello World, but okay. Just execute.
Let's try it.
Maybe it's working.
So, last step, we generate assets. So we just copy the runtime into the main file, and then we insert modules here. Okay, we do this, and take a look at which, in the graph, which modules included. The index, scope process stuff, the React stuff, and the big text stuff. So look here. We have to rewrite this graph because we have done scope hoisting. That is displayed. So 3 modules are included in this chunk. So we copy the first one. The first one is the index.js with module ID 0, and 0 is the ID, and copy this one. Copy this one here. The next one is module ID 1, and it's React bundle. Okay, copy this one. This one, and 2 is big text. Big text. Where's big text? Copy this one, and okay, just take a few. Did everything right? Seems good. Oh, we missed a semicolon here. Okay, async, we have the chunk runtime, simple, and also inject the module here, and the only module in this part is lazy, and the module ID is 3, lazy, copy this one, and so copy it. It should work. Hope so. Yeah. So I prepared an indexed HTML file because I probably get this wrong if I write this in my hand. So we just include main.js, and let's try it. Just drag and drop this file into this browser, and it doesn't work. Okay, let's debug it. Oh, I didn't correctly drop it there. You can debug it step by step, but make it backward here. So let's see. Somewhere in the call stack, it calls this chunk module method and makes a new promise, injects the script tag, and we continue Then a network request is done to async, which contains this magic JSON-P function, which is called here. Breakpoint here. Take a look at this one. And new modules contains a new module, and modules added to the modules, and which resolves the next thing, and everything goes right. Great. I tried this 2 times, but it never got it right. So luckily this worked. Okay, this was my presentation. Thanks. Any questions?
Why did you take so long?
The microphone?
Where's the world? So, what took you so long to implement Webpack?
Yeah, you basically have to write a code to do all this stuff. But it's a bit simplified compared to Webpack. We don't care about browser stuff and error handling, and actually we didn't implement the ECMAScript spec correctly, because in every module we take a simple one. We just edit. Normally we have to care about secular dependencies and create getters for exports, and yeah. So it's more complicated in real. But for the simple example, it works with very simple things, and the idea was to get an understanding what bundler does, and it doesn't matter if it's real. In reality, it's a bit more involved, but yeah. But it didn't take me so long to implement the first version of Webpack, which has only very basic functionality. All these extra features and more complicated and edge cases are the difficult part.
Yeah, so thanks to Tobias Copperfield. That's a great talk.